Hello students, welcome back to Info Science. So in today's video we shall discuss about the periodic classification of the elements. So we all know that matter around us, it exists in different forms, that is the elements, compound and mixture. So these elements, they are the substances which is made up of only one kind of atom, and we all know that there are different elements in the nature. Means there are many elements, and all these elements, they are classified into different categories. But how the classification it was done, because all the elements, they have their own different properties, own different characteristics, but how could we classify them into different categories? So in today's video we'll discuss all about this. So you see, first of all, let us know what is classification. So classification is very important thing because it helps in grouping or sorting the things. So though in case of elements, this classification, it helps in grouping of sorting or sorting of the elements based on their similarities and differences. Suppose even in the living organism also, the classification is very essential, because without classification we cannot identify what that animal or what the organism it is, in which group it will fall, or which kingdom or which phylum it will fall. So even in case of the element also, the classification is very much essential, because it makes their study of that element, it makes it much easy. So different scientists have made different attempts to study all these elements. So now we will know one by one about their studies of the different scientists, what they have given their opinion regarding the classification of the elements. So Dobber's trait. So the first, it is the Dobber's trait. Here this Dobber's is this, the scientist he have given one assumptions for the classification, that when the elements, they are arranged in the order of increasing atomic mass in the group of 3, then the arithmetic mean of the mass of the first and the third element is found approximate equal to mass of the central atom. So this was given by Dobber, and he have found only less than 33 elements during his attempt for classification of the elements. So you see, this is the Dobber's trait. So he have only in this method he have only discovered only less than 33 elements. So he said that the elements, they are, when they are arranged in their increasing atomic mass in the group of 3, then the arithmetic mean of the mass of the first and third element, it is found approximate, means it is found equal to the mass of the central atom. So you could see here, you see the lithium atomic mass is 7, then sodium atomic mass is 23, then potassium it is 39. So if you find the arithmetic mean, then how much it will find? And he said that arithmetic mean of the first and third element. So you see atomic mass of lithium, that is the first element lithium is 7, then the third element potassium is 39. So after finding the arithmetic mean, how much we got? It is 23. Then again the second one, calcium, it is atomic mass is 40, strontium atomic mass 88, barium 137. So the arithmetic mean of the first and third element, it will be 40 plus 137, the arithmetic mean divided by 2, the arithmetic mean is how much? 88.5. So according to him, that if the elements, they are arranged in the order of increasing atomic mass, that is in the group of 3, then the arithmetic mean of the first and the third element will be equal to the mass of the central atom. So this was given by the Dobber, the scientist. He have given this. Next, but this Dobber's trait, it have some demerits also, because he failed to arrange all the known elements in the form of trace. So this was the drawbacks of the Dobber's trade. So this was the first he was the first scientist who first tried to classify the element. He made the attempt to classify the element. Next, after Dobber's came the Newlands. So Newlands, he gave the Newlands law of octaves in the year 1864. So according to him, if elements are arranged, if they are arranged by the increasing order of their atomic mass, then the property of every 8th element is similar to its respective properties of first element. So, and in this way he only find out only 56, during his time only 56 elements were known. So you see, this was the Newlands law of octet, and he said that if these elements are arranged in the increasing order of their atomic mass, then you see the property of the 8th element. So here you can see the in the picture the property of the 8th element here: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, then fluorine. So the fluorine, it is the 8th element. So here, so the 8th element, he said that every 8th element is similar to its respective property of the first element. So this fluorine have the, according to him, so the fluorine have the similar property as the first element, that is hydrogen. So this was the thing which Newland find out in his attempt for classification of the element. So this was given by Newland's law of octaves, and he compared this to the octaves that is found in the music, and that's why this is known as the law of octaves. So in this form, like sa, re, ga, ma, pa, dha, ni. So this is the, in the form, he found this classification of elements in the chords of the music. Okay, and that's why he have given the name as Newland's law of octaves. So this Newland law of octaves, these have also some limitations. Okay, so this Newland law of octaves, it was not applicable for all the elements. It was only applicable up to the calcium, that is the lighter elements only, and the properties of the newly discovered elements, it did not fit into the law of octet. Then to fit the elements into his table, Newland placed even the dissimilar elements in the same slot, and also the same elements in different slot. So this is one of the drawback of this Newland octets, law of octets. Then according to the Newlands, that only 56 elements existed in nature and no more elements would be discovered in the future. So this was the Newland's attempt regarding the classification of element, and also according to him only the 56 element only existed. So this was the things which Newland have given in his assumptions. So now next it is scientist, the Mendeleev. So another scientist, Mendeleev, he have again discovered his thing of the classification of elements. So Mendeleev have given the periodic table. So that is known as the Mendeleev's periodic table, and was discovered in 1869. And according to Mendeleev's periodic law, he say that the properties of the elements are the periodic functions of their atomic masses, and in Mendeleev's periodic table, it is based on the chemical properties of element. So this, according to Mendeleev, he made the periodic table in such a way that it is only based on the chemical properties of the elements. And in his periodic table, it contains 7 periods, that is the horizontal rows, and 8 groups, that is the vertical columns. And when these elements, they are arranged, okay, arranged one by one in the order of the increasing atomic masses, the element with the similar properties, they occur at regular intervals. So this was given, all these things were given in the Mendeleev's periodic table. So this is the whole Mendeleev's periodic table. So you can see here, total here 7 periods are there, and 8 groups here, 8 groups are there. So you could see this one. So this is the Mendeleev's periodic table, and here it Yes, this periodic table, they have some merits, okay, some merits, because through this table only the modern periodic table was made. So this as a merits, as, or can say as the advantage, it was that some gaps were left for the undiscovered elements like the gallium, scandium and germanium. So you could see here some gaps were left. And then here as a merit, you see, he predicted the properties of the elements on the basis of their position in the periodic table, and he made in such a way that it can accommodate the noble gases, okay, all the noble gases, it can be accommodated when they were discovered, without disturbing the original arrangement. So before, you see, in the Mendeleev's periodic table there is no place for the noble gases, but he have made his periodic table in such a way that it can accommodate the noble gases when it will discovered, when it will be further discovered. So in his time the noble gases were not discovered, but he have left some place in the periodic table so that the noble gases, it can be accommodated. And also this periodic table, Mendeleev's periodic table, it was useful in correcting the doubtful regarding the atomic masses of some element. So these were some merits of the Mendeleev's periodic table. And also it has some drawbacks, as here the position of isotopes, it couldn't be explained, and also there's no any fixed position for the hydrogen, and there is the wrong order of atomic masses of some elements which couldn't be explained. And here many of the empty gaps, it remain unexplained. So he left so many gaps in the his periodic table that these gaps were, after the new periodic table though it was made, but still that gaps remain unexplained. So next, the last which was discovered was the modern periodic table, and it was discovered by Bohr's. So Bohr's, according to the Bohr's modern periodic table, here the properties of the elements are the periodic function of their atomic number. So you see here Bohr's, what he did, he took properties, as we know that the properties, it can be physical also, chemical also. So he took the chemical properties, and as we know in the chemical properties, it comes to reactivity, and reactivity means the valency, then valency means the, here it comes then the valence electron, and then valence electron system, it depends on the what, that is the atomic number. So the periodic table which was made by the Bohr's, that is known as the modern periodic table, here the properties of the elements, they are the periodic function of their atomic number. So this is the modern periodic table, you could see here. And now let us know about this. So you could see here in the picture, this is the same periodic table, but it is just in a detailed way, all the things part by part. So it is just in a detailed way. So which are the metals, which elements are the non-metals, which are the metalloids, so you could see here. So you see the elements in the modern periodic table, they are arranged in 18 vertical columns. So you could see there are total 18 vertical columns, and they are known as the groups, and there are 7 horizontal rows which is known as the periods. So the 18 columns, 18 vertical columns, they are known as the groups, and the 7 horizontal rows are known as the periods. So you see in the first period, so it has total 2 elements, that is the hydrogen and helium, and that is the shortest period. Then in the second period, it has total 8 elements, that is the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So total it is how much? That is 8. So this is known as the short period. Then in the third period also it has 8 elements. So this third and second period, it is known as the short period, okay. Then the fourth period, it has total 18 elements. So you can see here in the fourth period total, if you count it, it has only total 18 elements. Then again in the fifth period also, it has total 18 elements. So this fourth and fifth period, it is known as the long period. Then the sixth period, it has the 32 elements. So that is why it is known as the longest period. And as the seventh period, it is somewhat, it is incomplete. So that is known as the incomplete period. So again, if you come to the group, so the elements in the group 1, they are known as the alkali metals, because as they form water soluble bases. So all the alkali metals in the group 1, they forms the water soluble bases. So you could see the orange one, these are the alkali metals, that is the lithium, sodium, potassium, So these all are the alkali metals. Next, in the group 2, the elements, they are known as the alkaline earth metals because they are found in the earth crust. So you see in the group 2, that is the little bit yellow one, okay, there is the beryllium, magnesium, calcium. So these are all the alkaline earth metals, they are found in the earth crust. Then in the group 17 elements, they are known as the halogens. So that is the fluorine, chlorine, bromide, iodine. All these elements are known as the halogens as they are very reactive non-metals. Then the last, that is the group 18 element, these are the noble gases, which is also known as inert gas. That is the helium, neon, argon, krypton, xenon. All these elements are the noble gases. Then from 3 to 12 group, these are the, so you see in the picture, from 3 to 12 group, the middle one, so these are the transition metals. Then from 57 to 71, the down part, okay, so this 57 to 71, these are all the lanthanides. And from 89 to 103, the purple one, purple down one, you can see here in the picture, these are all the actinides. And here one important thing is that the position of the elements in the periodic table, they tells us about their chemical reactivity, how the reactivity is there in that element. So this is all about the classification of the elements, and which was given by different scientists. Okay, first we got the Dobber's trait, next we got the Newland law of octets, then the third one we got the Mendeleev's periodic table, and the last one is the modern periodic table, which was given by Bohr. So this is all about the periodic classification of element. So in the next part we will discuss about the trends. So till then we'll meet again in the next video.